It stands as one of the most remarkable achievements in human space exploration, a mission whose success story is nothing short of extraordinary. The Voyager spacecraft's enduring legacy. Launched in 1977, these twin space probes, Voyager 1 and Voyager 2, have been carrying out their groundbreaking research missions for nearly half a century. Their contributions have revolutionized our understanding of the universe, from exploring the outer planets of our solar system to making history as the first human-made objects to enter interstellar space. Their journey has offered humanity priceless glimpses into the mysteries of the cosmos and beyond. Yet, even the most ambitious and well-crafted projects are bound to face challenges, and the Voyager mission is no exception. As the spacecraft age, they are beginning to show signs of wear and tear, and the countdown to the end of their missions has already begun. Before delving into the Voyager probe's incredible accomplishments, let's reflect on the setbacks and near-catastrophic issues that have tested the ingenuity and determination of the engineers and scientists involved. For example, in 2022, an unexpected crisis arose when Voyager 1 began transmitting puzzling telemetry data. The information it sent back to Earth was nothing short of unintelligible gibberish. Curiously, the spacecraft continued to function properly in every other way, yet the data it transmitted made no sense. This anomaly left NASA's top minds scratching their heads as they worked tirelessly to diagnose the problem. After extensive analysis, they discovered that Voyager 1's attitude control system was at fault. It had mistakenly tried to route data through an onboard computer that had been shut down for decades. Fixing this issue was far from straightforward. It required months of careful investigation and testing. In the end, the engineers succeeded in redirecting the data transmission back to a functional computer system, restoring proper communication. Yet, just as the team breathed a sigh of relief, another crisis emerged, this time involving Voyager 2. The second probe, which had been traveling an equally impressive distance through interstellar space, suffered from an antenna misalignment that resulted from a human error. A command sent from Earth had inadvertently caused Voyager 2's antenna to drift out of alignment by 2 degrees, a seemingly minor error that had significant consequences. The slight misalignment meant that the spacecraft's data, sent across a staggering distance of nearly 20 billion kilometers, failed to reach Earth. Correcting this issue required a highly calculated maneuver known as an interstellar scream. This involved sending a powerful signal to Voyager 2, essentially shouting across the vast expanse of space. Given the immense distance, it took 18.5 hours for the command to reach the spacecraft, followed by another 18.5 hours for the response to arrive. The 37-hour wait was an excruciating test of patience for NASA's ground team. Yet, their perseverance paid off, and contact with Voyager 2 was successfully re-established. This victory was a testament to the unyielding spirit of the Voyager mission, but it also highlighted the challenges of maintaining communication with spacecraft that are billions of kilometers away. Over the years, the Voyager mission has faced numerous such challenges, each one requiring extraordinary technical ingenuity. One of the most nerve-wracking situations unfolded on November 14, 2023, when Voyager 1 encountered a new crisis. This time, the spacecraft could no longer package and send data from interstellar space to Earth. The culprit was a defect in the Flight Data System, FDS, a critical component responsible for collecting scientific data and converting it into compact packets for transmission. Once packaged, the data is sent to the Telemetry Modulation Unit, TMU, which transmits it to Earth. However, the defect disrupted the communication between the FDS and the TMU, causing the TMU to send an endless loop of meaningless zeros and ones, a digital equivalent of a broken record. NASA's engineers sprang into action, attempting to restart the FDS as early as December 23. Unfortunately, their initial efforts were unsuccessful, and it appeared that a simple reboot would not be enough to resolve the problem. The situation seemed so dire that some experts openly admitted that it would take a miracle to get Voyager 1 functioning properly again. Yet, in the world of space exploration, miracles do happen. By April of the following year, the long-awaited news broke. Voyager 1 was once again transmitting scientifically valuable data. The breakthrough came after engineers painstakingly narrowed down the cause of the FDS failure to a defective microchip. This faulty chip contained a critical program code that checked the sequence of data processing. Faced with the spacecraft's severely limited memory capacity, the engineers had to think creatively. They devised a brilliant yet complex solution, breaking down the program code into smaller segments and distributing them across various storage locations within Voyager 1's onboard computer. Each segment was meticulously rewritten to reference the new storage locations, and the team added script lines to guide the computer through the new code sequence. This meticulous adaptation was a remarkable feat of engineering, and when the new code was uploaded, Voyager 1 resumed transmitting data, a moment of triumph that underscored the skill and dedication of the Voyager team. Even with these extraordinary achievements, the reality remains that both Voyager probes are running out of power. To extend their operational lives, NASA has implemented a series of power-saving measures. These measures are crucial for keeping the spacecraft's essential systems running as long as possible. One notable conservation strategy involved deactivating a backup voltage regulation system, which had its own small power reserve to absorb fluctuations. By reallocating the energy originally used for this backup system, NASA has managed to keep the scientific instruments operational for a while longer. Nevertheless, these measures are not a permanent solution, and the energy supply continues to dwindle. One of the most critical challenges involves Voyager 1's thrusters, which are necessary for maintaining the spacecraft's orientation and keeping its antenna pointed at Earth. These thrusters operate using liquid hydrazine and are crucial for executing small, precise adjustments. Since Voyager 1's launch in 1977, these thrusters have performed countless tiny bursts to ensure proper alignment. Over the decades, however, deposits have built up in the fuel lines, causing them to gradually become clogged. In 2002, NASA had to switch to a second set of thrusters as the original set degraded. But by 2018, even the second set showed signs of serious wear, prompting a switch to a third set, originally intended for course corrections. Fast forward to 2024, and even these third thrusters are now nearing the end of their functional lives. The inner diameter of the thruster nozzles has shrunk alarmingly, from the original 0.25 mm to just 0.035 mm, less than half the width of a human hair. Faced with this critical issue, NASA engineers made a bold decision to reactivate one of the previous thruster sets. This task was not without its risks, as the inactive thrusters needed to be preheated before they could function. Preheating required a substantial amount of energy, a precious resource that the spacecraft could ill afford to waste. After careful consideration, the engineers decided that the safest course of action was to temporarily shut down one of Voyager 1's main heating units, despite the potential risks. On August 27, 2024, this delicate operation was carried out. The main heating unit was turned off for 1 hour, allowing the thrusters to warm up. During those 60 minutes, the team anxiously monitored the spacecraft, knowing that any miscalculation could spell disaster. Given the communication delay of 22.5 hours each way, the outcome of the maneuver remained unknown for nearly a full day. When the signal finally arrived, confirming the success of the thruster swap, the entire team breathed a collective sigh of relief. It was a temporary reprieve, but a significant one, allowing Voyager 1 to continue pointing its antenna toward Earth and transmitting data. Yet, even this victory came with caveats. The reactivated thruster set, though functional, is already compromised by the very same deposits that led to its initial shutdown. And the challenges are far from over for Voyager 2, either. The spacecraft has also had to sacrifice some of its capabilities to conserve energy. Earlier this year, NASA made the difficult decision to deactivate one of Voyager 2's 5 remaining scientific instruments. The chosen instrument was a plasma sensor designed to measure solar wind particles, a task that had become less relevant as the probe ventured deeper into interstellar space. The deactivation of the plasma sensor raised concerns about potential gaps in Voyager 2's future datasets. Fortunately, the impact of this decision is minimal. The instrument was originally designed to study the solar wind, which flows outward from the Sun. But now that Voyager 2 is in interstellar space, the plasma flows have reversed direction, moving toward the Sun. This means the plasma sensor was no longer effectively positioned to gather useful data. In contrast, the probe's plasma wave subsystem remains operational, continuing to provide critical information about plasma currents and turbulence in the interstellar medium. Looking ahead, The measures taken to conserve energy should allow both Voyager probes to continue transmitting data into the early 2030s. This longevity is nothing short of astounding, considering the original mission plan estimated a lifespan of only 5 years. The fact that the Voyagers have exceeded expectations by such a wide margin speaks volumes about the skill of the engineers who designed them and the ingenuity of the teams that have kept them operational for so long. When the day finally comes that the Voyager probes fall silent, they will continue their journey through the cosmos, drifting silently among the stars. These silent travelers will carry humanity's story, immortalized on the golden records affixed to each spacecraft. These records contain sounds and images from Earth, a time capsule of our existence, intended for any intelligent beings that may one day find them. Even when the probe's power has long run out, they will remain as silent emissaries of our civilization, telling the story of our world to the universe for millions, if not billions, of years. If you've enjoyed this journey through the incredible Voyager mission and want to stay updated on the latest space exploration stories, don't forget to like and subscribe. Join our community and be a part of humanity's ongoing adventure into the final frontier. Thanks for watching, and see you next time.